previous lecture, we considered a situation that the samples are independent with each other. There is another situation that the samples are dependent with each other. In this situation, we should use dependent sample t-test. We also call it paired sample t-test. So if there are two samples that are dependent with each other, for each observation in one sample, so we can find another related observation in another sample. So we can match each observation from the first sample to the observations from the second sample. Therefore, we have matched a pair of observations from two samples. For each matched pair of observations in the two samples, we can calculate the difference between the values of the matched pair. As previously, we can treat the mean of the difference between the values of the matched pairs as a variable, and this variable is t-distributed. Let's take a look at the t-statistics for the two dependent sample t-tests. So t-score for the two dependent sample is equal to the mean of the first sample minus the mean of the second sample divided by the standard error of the mean difference between the value of the matched pairs. We calculate the standard error for the means of the difference between the two matched pairs. We use the standard deviation of the difference between the value of the matched pairs divided by the number of observations square roots. For this t-statistics, it's t-distributed with degree freedom equal to the sample size minus 1. The number of observations in this first sample is equal to the number of observations in the second sample, because we need to find the matched pairs. Let's take a look at the example. In this example, we have two samples. Those samples, they are dependent. We have first sample, it has 4 observations with the value 100, 70, 50, 70. We have second sample with value 80, 90, 75, 60. We match the observation from the first sample to the observation in the second sample. Here we have the 100, the first observation in the first sample is matched with the first observation in the second sample. And the second observation in the first sample is matched with the second observation in the second sample, etc. So the same thing for the third observation in the first sample matched with the third observation in the second sample. So after we match those observations, we try to calculate the matched difference. The first one will equal to the 100 minus 80, so we get 20. And the second one will equal to the 70 minus 90, it's equal to the negative 20. We have 50 minus 75 equal to the negative 25. For the fourth matched difference, it's equal to the 70 minus 60 equal to 10. So finally, we get the difference between the value of the matched pairs is 20, negative 20, negative 25, and 10. We have the number of observations is equal to 4, so which means the degree of freedom for the t-distribution is 3. Then we try to calculate the mean of the matched difference value. It's equal to the sum of the 20. So we add 20 -20, -25, and 10 divided by the number of observation. So it will be equal to the -15 divided by 4 is equal to -3.75. Then we calculate the variance of the matched difference. The variance will be equal to the value minus the mean. Then we get the square that adds all of the observations in the matched sample. After we got the sum of them, we divided by the number of observation minus 1. So here is 3. Then we get the variance is equal to around 500. Based on the variance, we can get the standard deviation of the matched difference is equal to 22.13. Based on the standard deviation, we can get the standard error. It's equal to the standard deviation divided by the square root of the number of observations in the matched difference. So finally, we get the 11.07. This is how we calculate the difference, the number of observations, the mean, and the standard deviation, the standard error. Later on, we can use the statistics to calculate the t-score. Let's take a look at the statistic tests. In this case, we set the significance level 0.05. So which means we want to have 95% confidence in our results. If we do not know which mean of the samples is higher, we will use the two-tailed test. For the alternative hypothesis, we said the means are not equal. So we will reject the null hypothesis if the t-score we calculated based on the information we have is larger than the t97.5 percentile or less than the t2.5 percentile. Those two values will be the threshold. And if the t-score we calculated is between the value of the t-score we calculated is between the two thresholds, we will not reject the null hypothesis. Otherwise, we reject the null hypothesis. And in favor of the alternative hypothesis, the mean of the first sample is different from the mean in the second sample. If we know that first sample has a larger value on average, alternative hypothesis, we can set the mean of the first sample is larger than the mean of the second sample. And in this case, if the t-score we calculated is larger than the t-distribution with 95 percentile of the t-distribution, so we will reject the null hypothesis and in favor of the alternative hypothesis, which means the mean of the first sample is larger than the mean of the second sample. Otherwise, we do not reject the null hypothesis. If we know the first sample has smaller values on average, we can set our alternative hypothesis. The mean of the second sample is larger than the mean of the first sample. If the t-score we calculated is bigger than the threshold, we do not reject the null hypothesis. Otherwise, we will reject the null hypothesis and say that the mean of the second sample is larger than the mean of the first sample. The hypothesis here will be the t-value with 5 percentile of the t-distribution, because here we set the significance level equal to, we want to have a 95% confidence level. Let's go back to the previous problem we mentioned. So in this problem, we know that the clients They have their own information system that projects the amount of returns in each of the following 12 months for some project ABC. The audit team come up with their own projection of the 12 months returns. The client's average estimate for the month's return is 35,000. The auditor's average estimate of the monthly returns is $39,000. And we know the standard deviation of the difference between the client's and auditor's return estimate for the 12 months is 2,000. We want to know whether the client's estimate of the monthly return is significantly larger than the client's estimate on average. So since the month estimates are generated using the same data for the same month, so there's two samples that can be, those two samples are not independent. So in this case, we need to use the dependent sample t-test, and we can match the observations in the two samples. So let's take a look at how can we solve this question. So we know the number of observations in the two samples is 12. We know the client's estimate for the monthly return is 35,000. Auditor estimate for the monthly return is 39,000. We know the standard deviation, so we can calculate the standard errors for the difference of the two sample means. So we get the standard errors equal to 500. It's around 600. Test hypothesis here we can set. The non-hypothesis is there is no difference in means. Alternative hypothesis is one-tailed hypothesis. It says that the mean of the second sample is larger than the mean of the first sample. The t-statistics will be equal to the difference between the first sample mean minus the second sample mean, divided by the standard errors we calculated before. So we get the t-distribution equal to the negative 6.93. This t-distribution with a 11-degree freedom. So we can calculate the t-value of the 5 percentile and the 1 percentile respectively equal to negative 1.8 and negative 2.72. Because the t-value we calculated is less than both of the values, the t-value of the 5 percentile and the t-value 1 percentile, which means we reject the null-hypothesis and supports and in favor of the alternative hypothesis. So we can conclude the auditor average estimate is significantly larger than the client average estimate with both 95% and 99% confidence.